Well, hello everybody. Welcome into Great Atmosphere here. Happy Friday here on this February 23rd of 2024. Wanted to get started today by taking a look at the global sea surface temperatures right now. Of course, this is in degrees Celsius. We, generally speaking, have a few things going on here. So we have a very warm Indonesia and Oceania, a very warm Indian Ocean, as is typical for this time of year. As you know, Southern Hemisphere is currently on the waning edges of their summer, so this is kind of their main tropical season, as it were. But interestingly enough, and this is what has got weather Twitter all in a buzz recently, is the Caribbean Sea is sitting at about 27 degrees Celsius right now, which is high 80s. Those kind of sea surface temperatures are not expected to be anywhere near that area of the Atlantic until usually early to mid-May. Seeing as though that we are in mid-February, it has caused quite a bit of a kerfuffle among everybody. And the main instigator and a main threat, I suppose, that everyone is worried about is, one, people are concerned about the efficacy of the Gulf Stream. We'll leave that conversation for another day, but that has its problems as well. But the other one is, what does this mean for the Atlantic hurricane season coming into 2024 as we get started here? So, having exceptionally warm sea surface temperatures, that is certainly one part of the equation when it comes to hurricanes and their genesis, but it's not everything. And there's one particular report put out by Jeff Berardelli, and I can't remember who else did it. Well, Berardelli put it together, and he had I believe his first name is Brett, but obviously that does nothing for you. But he put together this report. He works out of a Florida television station for WFLA, and he put together these charts. The North Atlantic sea surface temperature anomaly. You see, this is the temperature anomaly for last year. Obviously, it broke a lot of records. And 2024 is already a step ahead above even that outlier of a year. And this 2023 really didn't set itself apart until we got into the summer months. We came out of the gate here in January already about 1 to 2 degrees higher than normal average sea surface temperature. Brian McNulty, that's the name of the other meteorologist who put this together. Ultimately, he came out to it. It was about a 1 in a 280,000 year event. Now, that's not saying that happens once every 280,000 years. That statistics, it's a fractional percentage. It can happen year over year. Technically speaking, it's just exceptionally rare. That's just how it's a way of. What is that? It's a 0.00034% chance of it happening based off of a scale that goes back to, actually this is a 30-year time scale here. So, be that as it may, and then we have our temperature departure from normal here. Obviously, it's way elevated for this time of year, and then they equate it to other active hurricane seasons. So February 2005, we had 28 hurricanes, which is exceptionally high. And that is how the anomaly looked. And then you can see how that's evolved over the years. And once again, temperature is just one element to this, but February 24 obviously looks the most orange on this scale. And they're putting a correlation in early in here. So another big factor is where ENSO, the El Nino Southern Oscillation, is currently going to be at. And we are seeing, according to the Climate Prediction Center, a trend towards ENSO neutral. The El Nino that we experienced this winter is starting to degrade, and we can see that in just a little bit, what the proof is regarding that. But this is the sea surface temperature anomaly that is expected here in July, August, September. The Eastern Pacific goes cool, which is, this is according to the National Blend of Models, the NMME, but generally cooler signal in the East Pacific signals a La Nina. And the other last part of it, which we'll get to also in a little bit, is the precipitation anomaly. This is what the NMME is expecting in terms of, if we got a large stream of moisture coming in from Senegal and Cote d'Ivoire and Sierra Leone off the West African coast, well, then obviously we would expect to see that moisture transport come in the form of hurricanes. But what are the major factors here? Let me refresh the page. But it's not the only thing that's going on. One of the things that I definitely wanted to draw attention to before we get into into the hurricane analysis is just how kind of anomalous a lot of the weather has been across the entire world. And, you know, here in the United States, we've had a relatively warm winter. I would say actually a record-breakingly warm winter, as we talked about on Wednesday. And a lot of people are wondering, it's like, oh, well, is this the case of, like, you know, full-on global warming, the whole 9 yards? And sure, the Earth is warming. We get that. What the human role is in that is not officially understood. We have our inclinations, but the cold air all has to go somewhere, and the cold air currently this week is sitting over the general Eurasian continent in Siberia, all the way down into Mongolia, Kazakhstan, and now even the southern reaches of China. Shanghai received I believe, one of its lowest high minimums in, I think, over 30, 40 years or something. Didn't get above freezing in Shanghai, and Shanghai's latitude puts it right about there where my cursor is. It's about on the same latitude as Dallas, Texas. And generally it usually has a lot more tropical flow coming in from the West Pacific. But as we're seeing here, this is 28 degree Fahrenheit temperatures that are, if you look on it from a latitudinal perspective, that's well south of the border here. So in the middle of Mexico, you would get below freezing high temperatures. That's quite significant, and not something that area is particularly used to. And then we go a little bit further higher up in the latitudes, and we're seeing negative 19s. It's quite cold over Siberia at the moment, and that's currently just where the polar vortex is sitting, kind of trapping in that cold air, while warm air from the primary ocean currents are being advected in along the North American continent, and that's why we have been so warm over us and over Europe specifically so far. We can also take a look at the sea surface temperature anomaly here. So obviously, generally speaking, the entire Atlantic is well above average, with some pockets in the Caribbean or in the Gulf of Mexico that are a little bit divergent right there. Still at the surface, we still have our general El Nino 3.4 composite is still registering. But if we take a look at what this looks like in terms of the actual depth in the ocean, we can see here. I don't know if I could pause this, but essentially what will happen is, you know, this is on a longitudinal basis. So if we have our international date line here, right, and then we'll have the Americas, and then we'll have well, I guess I'll put America, and then we have Asia over here, right, and then this has to do with sea depth, right. So this is the surface of the ocean, and this would be meters down. So what happens is we'll get westerly wind bursts that come over the West Pacific that ultimately work to cool a lot of the ocean waters in that particular region. Those get downwelled as the cycle goes in this kind of direction like this, right? And then as those tropical wind currents kind of move everything forward, the current kind of takes it in an underwelling all the way across the ocean. Up and into the Americas and the east and off the west coast of the Americas, and particularly Ecuador and South America, that region. And eventually, this little pocket of cold that we're seeing now will make its way to the surface, and then it'll start to affect our sea surface temperature anomaly map in a quite significant way, and ultimately signal the beginning of a La Nina season. So that is currently that's currently what they're looking at and what they're expecting out of the Climate Prediction Center for El Nino. And then I think we can actually take a look. Yep, so this is what the model predictions are looking for. So right now we are sitting at a quite significant still observed El Nino, about 1.8 degrees above average sea surface temperature. We expect that by the time we get into the midsummer months for us to be in an ENSO neutral state. I believe that probability is now increased to a 79% chance. And then it's kind of, if you take out the outlier models, we generally are looking at about a three quarters of a degree to a full degree La Nina as we go into the winter. So that's, and one of the things that is important to understand about the La Nina, and pretty much in hurricane generation in general, is you need a lot of different components in order for hurricanes to kind of form. So in the reference to, let's say, last season, we, as you saw on the chart, we did have exceptionally high sea surface temperatures, and a lot of people were making a big to-do about that because they were like, hey, warm waters equals hurricanes, am I right? And they weren't right. That is not how that worked. We actually had a very reserved hurricane season. We only had one major hurricane landfall in Irene, and generally speaking, a lot of the hurricanes that did form were either out to sea, they were blocked off by the Bermuda High, and the Caribbean never got going, despite having very minimal wind shear. And it's not just minimal wind shear, and it's not just sea surface temperature anomalies, or a positive sea surface temperature anomaly, and it's not even like a high amount of moisture, because the Saharan dust layer did not even affect most of the middle part of the season. What everyone seems to miss, and I don't understand why they don't, is that in order for any of those hurricanes to form, they need initiation. They need energy to form out of them. And one of the things that no one really takes into account is the Indian Ocean Dipole. Now, what is the Indian Ocean Dipole? Essentially, it's a mini El Nino, essentially, that only exists in the Indian Ocean corridor. So in an IOD positive time frame, we would expect to see much more convective initiation in the reaches of Eastern Africa, and then we would expect to see very limited initiation over Indonesia, Western Australia, and Southeast Asia. And what that essentially does, in terms of, if you were to cut this open, you would have air that would, if you were to consider this like a Hadley cell, essentially, you would have air that goes across this tier right here. It would rise over East Africa, and then you would go down, go west back this way, and diverge at the surface, which would be prohibitive. You get a lot of droughts, you wouldn't get a lot of rain, you wouldn't get a lot of tropical initiation, you wouldn't get a lot of that stuff, whereas conversely you would get the opposite. You would get the opposite in East Africa, and that's in an IOD positive time frame. In the event that we have IOD negative time frame, the opposite would happen, where we would expect more drought over the Sahel, and we would expect more convective initiation and lots of tropical flooding rains over the Indonesian archipelago, western and northern Australia, and Queensland. So that is the Indian Ocean Dipole in a nutshell. And what typically happens is that when the IOD is positive, we get obviously a lot more uplift. We get a lot more convection in the East African, on the western slopes of the East African ridge. Some people don't. I don't know why we're zooming in, but we are. Anyway, so many people don't really know, but there is a lot of mountains. Some of the highest mountains in the world, Mount Kilimanjaro, K2, they're all here on the East African ridge, and the overall flow pattern goes kind of like this, right? So on those westward slopes, this is where their lee side lows form and create a lot of the tropical initiation and energy, and you've heard this before, tropical waves that ultimately begin a lot of those particular systems. So what does that mean for us? Well, in an IOD positive, or tilting, or I would say tilting more negative from a positive, so we're going from a higher value to a lower value, because there is a global mean time lag when it comes to effects that affect our hemisphere with the IOD, because it is very far away. When it's IOD positive and they get a lot of convective initiation over East Africa in the fall time, right? The fall time for us in the northern hemisphere, the next fall, technically speaking, will mean that a lot of that convective initiation will start to move this way and kind of do it in this kind of pattern. Does that path look familiar? That's the general path for the Atlantic hurricanes. So what does that mean for us next year? Now, last year there was a IOD negative track across Africa, so that valve was kind of shut off. That my opinion, is why we did not have a lot of convective initiation in the Atlantic, because there was no initiation to be had in the lee of the East African Ridge for any of. There was major drought across the Sahel last year, and that was primarily due to the IOD. This year, it's the very drastic opposite, and we can see what that looks like now. For the majority of 2023 so far, we have been an IOD positive on a pretty obscene scale. Now, it's not necessarily the fact that how high the IOD positive is, and this is kind of still the question that's up in the air at the moment in my head. How fast does this revert back to IOD negative? Now, if you look in this time series that goes back to 1992, the IOD does not like to stay positive for long. It'll stay negative for a long time, and this contributed to a quite significant drought and a quite significant hurricane drought, mind you, across the world essentially when this was in IOD negative for a long period of time. But you can see in the years that went quickly. In a negative sense, so you see like where the slope is negative, very negative slope. Those are the years. So let's point them out for everyone. So we have 1998, very significant hurricane year. Okay, then we have 2005, very significant hurricane year. We have 2008, hurricane year. This one is interesting. 2010. Very significant hurricane year, but we didn't have a very positive IOD, but it went way down. It went straight into a very strong, the strongest negative IOD that we've had. That mean slope generated a very vast hurricane season. Then we go into the next round. We got 2015. And we go into 2020. 2020 was our very last significant hurricane season because it had that significant dip from positive to negative. Now we are experiencing one of the highest positive IODs we've seen in a long time. How? If we were taking bets, it doesn't like to stay positive for long. The atmosphere likes to self-correct itself out of it. If this were to go down like this, well, I would say we're in for kind of a for kind of a storm of some regard, an S storm, if you will. That would not be good. If we went from that positive in IOD all the way down and into a -1 or -2, that would be a significant hurricane season because we get a lot of convective initiation from the mean time lag that we'd expect from the IOD. So that's kind of my soapbox here. It's not all about just moisture. It's not all about moisture or lack of dry air. It's not all about sea surface temperatures. It's not even all about deep ocean heat content. It's not even about wind shear. It's about where does the energy come from? Where is the initial convective initiating in the first place? So yeah, that's my soapbox for today. If that verifies, I'm scared. That's essentially what I'm saying. Anyway, so another thing in terms of what we're looking at across the U.S., we'll get a little bit closer to home now. In terms of how warm it is, I thought this was interesting. This is looking at the daily temperature data across Boston Logan Airport. And what you can see here in this like very faint blue line is the freezing level. And the top of all these bars is the observed high that was observed for that day. And if the top of that blue bar is above the freezing level, then obviously the high was above freezing for that day. Now this is in Boston in winter. There should be a lot more days where the high is well below freezing. Typically, this time of year, we actually, you can see the observable averages. Right down in the January, they're expecting more, like that's where they expect to be, like kind of in that regard, more leaning towards, I'd say the majority of the average in that brown area is below freezing in terms of what their expected temperature is in that time. So besides the January cold snap that we had, all of February thus far, since the middle of January, and then before that we had January into December, all the way over here. I mean, it's since the beginning of winter, the only time that the high temperature in Boston has been below freezing has been in that January cold snap that we saw when the polar vortex was over North America. So that's interesting. And then we can see what that looks like across the rest of the some other big areas. This is the World Trade Center in New York. It doesn't have the cool colors, but you can see the freezing level well above average, with the exception of that January cold snap, where it got to 27, 28 on just 2 days. Every other day of the whole entire winter, it's been above freezing. And even look at those lows. The lows are still well above average in that regard as well. They're well above freezing, with the exception of some little ones that barely scrape it. So it's been an exceptionally warm winter for everybody. And also, I saw a map earlier today that Minnesota has gotten less than, or central Minnesota, like up in the Duluth, Minneapolis, Twin Cities, St. Paul regions, only received 4 inches of snow for the entire winter thus far. That's crazy. So really interesting, anomalous winter that we've had. Very warm, not much of a winter at all, and we only got another week or so before things start moving into the transitional month here. So it'll be one for the record books, that's for sure. This 23 to 24 winter. Taking a look at what we have for the radar at the moment, we have an interesting little setup. We have our subtropical ridge, which generated a little bit of a trough setup, a little bit of a shortwave trough setup in the subtropical region that made its way across the Appalachian Mountains, and produced, actually before that, some of the season's first major hail events over the Ozarks, and in this particular region of the Ohio, Tennessee, and Mississippi River valleys. Actually got some pretty severe hail in like this pretty much area, pretty lines, or little lines right here. We had little hail streaks that popped up there. First hail reports of 2024 for the United States popped up right there overnight as the system started to move through. We still have some overlying cloud that has been existing over the mid-Atlantic today, but generally speaking, drier air is starting to make its way in, but that is not going to be the end of it, because lo and behold, we have a little bit of another little shortwave that is beginning to generate up in the UP of Michigan at the moment now. And we can see the side effect of that. So we see the rain that is moving off. Main front is already off the coast, and then we have some backfilling coming in, very skinny cape, inverted V profile type storms that are going to be making its way across the East Coast. Actually, that's the system we're talking about now in terms of that. But we had some backfilling coming in off the lee side of the Alps. But we have another area of convection that's beginning across Wisconsin, and in addition to that, some subsequent lake effect coming off Superior across the UP of Michigan. Now, what does that look like on the map? Well, it's this particular area right here. Why is this? It's not like this. Come on, Pivotal. Work with me here. There you go. Perfect. Okay, so this is looking at Saturday at 0Z. So this would be about tonight, Friday evening. I need to get a better pen here. Here we go. That's probably a little too thick. We're going to go back here. Apologies about the wait. So what we're looking at is this little shortwave that exists right there. That is going to be our convective initiator. We have meridional flow coming in from a northerly direction that's going to be interacting with a warmer air mass. And the main storyline here is that this is the polar jet that we've been talking about ad nauseum for about a week or so. The polar jet has fully come into play here, and it will start to begin its gradual merge with a subtropical jet that'll start to influence a lot of our transitional storm season as we move forward into the week. And this is kind of the precursor to it as we go forward into the next day or two. So we see the transition of that shortwave trough. The majority of that jet streak in the polar jet is on the windward side, so it's on the westward side, so it's not on the east. So we know that there's going to be it is going to be strengthening. So you see whenever. Yep. So we see when we have a trough like this, or we have a generalized indentation that goes in this direction, right? So that if we cut that in half, and the majority of the energy is on the westward side here in the mid latitudes in the northern hemisphere, we would expect this to be a strengthening storm system. And I don't know why it's doing this, but that's a good thing to know. Thank you for that. As we move forward, you can see. Still recording, okay. And essentially, if this wants to actually cooperate with me, 1 second. So that'll eventually start to merge, and you can see that merging take place. We have the polar jet right in around here that starts to merge with the subtropical here, and that'll start to spark off a little bit of initiation in the Carolinas region over the midday tomorrow. Now, one of the important elements that we're going to be talking about for sure into next week is the beginning of that main sequence of the polar jet merging with the subtropical and beginning a lot of when you're merging cold and dry air from above the polar jet region, that's essentially Arctic air, and then when you merge that with subtropical jet, which below the subtropical jet in the mid latitudes or in the middle atmosphere is warm, moist tropical air, and they're going in different directions, you're going to get yourself a lot of convective initiation, you're going to get a lot of spin, and you're going to get some thunder boomers. Now, the interesting thing about this particular one is that the SPC has actually highlighted an area on day 5 and day 6, 50% chance. Usually they don't do anything past the day 4 outlooks for severe unless they are highly confident or highly scared of potential of a highly potentially bad thing. It's still to be seen whether or not that is which of those it is, whether it's scariness or high confidence that something will happen. But they have it moving in through the Midwest on, I believe that's Tuesday, and then Wednesday moving more further into the Mid-South and the Southeast and the Deep South. So that'll be an interesting thing to watch. But we can take a look at our flagship models. We have the GFS on the left and we have the Euro on the right. And we'll take a look. This is now at 6 a.m. on Tuesday. Now you notice there's still not a lot of confidence between the two. Remember, the Euro has performed better over the past few months compared to the GFS. So we're always going to look at the Euro first, and then we're going to look at the GFS to kind of get a gauge on what our general confidence is in the forecast as a whole. As just a general rule of thumb. Now the Euro is particularly quick, and it's not as severe. You see they keep a lot of that initiation actually further up into the northeast near the Midwest and Ohio. Meanwhile, the GFS has this becoming a much more meridional and tilted system that stretches all along down and into the Arklatex region, all the way up and into the Midwest and into the Gulf of Michigan. So that is an interesting little development, but you can see how fast this moves out. You know, like this is on noon on Wednesday. Euro has this pretty much already moving out to sea, and the GFS just has this kicking off. And it's particularly bad, particularly to the timing of the GFS, because if this was coming in during the heating of the day on Wednesday, that could be a recipe for some quite significant. And the fact that it has backfilling snow on the back end just kind of shows just how Arctic that this dip of air is. So the polar jet, you can literally see it right here, is going to be doing something like this. And then you'll always have the subtropical jet and El Nino year doing that. And that convergence zone is going to be a troublemaker for sure, if they do collide in that particular sense. And then, interestingly enough, afterwards, the Euro is quite wet on the back end. We have high pressure building in off the mid-Atlantic coast, according to the Euro, and then it'll start to open up the Gulf a lot more, creating more of a rain shield event that comes in on the back end, whereas the GFS keeps that high right on top of the southeast, keeping us high and dry. So not a lot of confidence pretty much from Monday out. And timing-wise for the system is still up in the air by about 12 to 18 hours. So still a lot to be kind of discerned from it. That's why that the SPC hasn't kind of done anything else in terms of warning anybody. They know that the situation is quite interesting and is kind of a sign of spring. And it is the first major severe threat of the year, potentially. But there's just not a lot to go off of at the moment. We could take a look at what the GFS particularly is going to be looking at. Just to kind of get an idea of what maybe it's thinking in terms of overall synoptic, analytics regarding this particular system. You can see the lows start to form very high up and into the Dakotas, and it'll start to bring down a lot of that cold air reform. So you can see there's actually two lows. There's one low. I made it sounding again. Sorry, Pivotal is just my favorite website. So we got a low that forms here, and then we have another low that forms in its typical area in the panhandles, and then eventually this will be like the parent low, right? We have an extending cold front, and then we're going to have another cold front on top of that. These two will merge, and then the end result essentially would mean I would expect at least a QLCS to kind of form as this wraps around this stays more stationary, will probably move like this. This will go further more into the Mississippi River Valley region to form a big line of convection along that front, backfilling cold air on that end as well. You can take a look and see if that wish does come true. So that's essentially what I'm seeing here. Yep. So definitely much more of an easterly threat according to the GFS. Tennessee, Kentucky, Indiana, Ohio. And then we'll see what happens in the Mid-Atlantic. That's a little concerning that we get out into the Carolinas with that. And then the 540 line dips all the way down into Tennessee, which is interesting. It's a lot of cold air behind this, high pressure building in immediately. So really interesting thing, and it wraps up quite. Ooh, that's a 972 low right over Nova Scotia. So that should increase a lot of. That'll be a gale warning, in up there in the Canadian Atlantic. But yeah, it's certainly an interesting kind of look-see there. And then the GFS dries us all out. It has a little bit of a backfill right there. Okay, so the GFS is just extremely late because it does have high pressure that builds off of the coast, and then it'll reinitiate a lot of that convection on the as it opens up the Gulf moisture next week. It's just very slow. The Euro is about almost a full day and a half ahead at this point. So interesting little phenomenon there. We'll definitely take a look at it. I just want to end on looking at what that polar jet is definitely looking like. So this is what it looks like currently. It's a little discombobulated, a little bit all over the place. We definitely see the polar jet forming over the Aleutians, but the subtropical jet has generally been kind of fizzled out. You know, it had its major atmospheric river event that we've been talking about over California, and then that shifted over Mexico and over Florida. That gave it a pretty good soaking last week. Postponed a bunch of sporting events like the Daytona 500 and whatnot, but that essentially is gone, and it's going to be dominated now by these major generalized trough areas, and the polar jet might start to become more dominant as we go forward in time. We can see that simulated here. This is also the GFS's interpretation of the models. We can see that we're going to get out to where it thinks that this is all going to kick off about noon on Wednesday. And yeah, so that's exactly what we're fearing here. So we have our polar jet right here, and we have a mixture of subtropical jet starts to go in again, and see this main line right here, that jet streak maximum. Not good news. And then interestingly enough, we have another low that sets up right over here, and this will be our next system that comes in more than likely about 5 to 7 days later. Typically, when it comes to transitional periods in the spring, that is our time frame for getting storm systems across the middle of the country and into the southeast. We're on about a 5 to 7 day trough regeneration timescale in terms of getting more storms in and around the area. So that is generally what we are expecting here. Quite a lot to talk about, but got a lot to be concerned about in both the short term and potentially the long term. Particularly, I'm very worried about the Indian Ocean Dipole and how fast it drops off from it being in its positive phase coming up in the next few months. Definitely something I'll be keeping an eye on. But once again, folks, this has been Great Atmosphere. My name is Zach. I'll be doing videos like this for you every Monday, Wednesday, and Friday in the afternoons. I appreciate your subscription if you're so interested. I'm based in the Southeast. I'll be doing the majority of my forecasting work for the Southeastern region and in that particular target time frame. But obviously, I'll be talking about other stuff as it comes up in the news. So I appreciate you tuning in, and I'll see you on Monday. Have a good weekend. Take care.